get ready to blast off into the incredible world of brain-computer interfaces. Neurocareers Doing the Impossible is taking you on a journey to meet the fearless pioneers pushing the boundaries of what's possible. In this special series, we'll be shining a spotlight on the nominees and winners of the International BCI Award, one of the biggest and most prestigious awards in the BCI world. You'll hear from BCI professionals as they share their revolutionary work and get a behind-the-scenes sneak peek at what it takes to be a winner. So, buckle up, grab a snack, and get ready to be amazed as we explore the impossible becoming a reality in the world of BCIs. But before we blast off, I want to give a big thanks to the co-host of this BCI Award edition on our podcast, Dr. Christoph Guger and GTech Medical Engineering. When I was a faculty member at the University of Cincinnati and Cincinnati Children's Hospital Medical Center, my team and I did some pretty amazing stuff for patients needing epilepsy surgery. We would put special sensors, also called grids, directly on their brain to prepare for surgery and create maps of their brain in a much faster and safer way than is usually done. It's called high gamma mapping, and it lets us figure out in just a few minutes the essential parts of the brain that need to be spared during surgery. Can you imagine? You can create a map of language, motor, and even math processing in no time. It was the first time this innovative technology was used at Cincinnati Children's Hospital Medical Center. When I moved to Florida, I established the first functional brain mapping and BCI program at Florida Hospital. I continue to use high gamma mapping to help epilepsy patients avoid losing their ability to speak or move after surgery. But even cooler than that, I created brain-computer interface studies that let patients control things with their brain in real time. Our patients could even spell words with incredible speed by just using their brains. No hands involved. I also discovered that brain-computer interfaces could help patients move their chronically impaired hands or legs years after a stroke when not much else could help them. So, I started working with the faculty from Advent Health University to help these patients restore their ability to use their hands. I received special training for it, and it's still mind-blowing how cool it is. My favorite part of what I do is teaching. At my established Institute of Neuro Approaches, I've integrated all my experience and knowledge into a unique course on brain-computer interfaces. With graduate neurobiology students, we started with theory, and then I gave them the BCI equipment so they could have hands-on experience working with BCIs. It significantly improved the way students learn, and they absolutely love this practical part of learning how to use neurotechnology. And all of this was made possible thanks to GTech's awesome brain-computer interface technology. They have everything from high-tech up to 1024-channel EEG systems to wearables, tools for neurorehabilitation, such as the medical-grade system recoveries and educational kits with unicorn hybrid plug for learning how to work with BCI technology. But the most important part is their support and care. I have enjoyed working and collaborating with Dr. Christoph Guger and GTEC employees for over 15 years, and I hope for many more successful years ahead. So, if you are interested in GTEC's brain-computer interfaces and neurotechnologies, check out their website at gtech.at. It's worth it. And keep in mind, I do not receive any financial support from GTEC and share my honest opinion supported by many years of experience working with their equipment. Dear listeners, welcome to the Inspiring Neurocareers Doing the Impossible podcast, BCI Award series, where we delve into projects that are pushing the boundaries of neurotechnologies. Today, we shine a spotlight on a remarkable project that has captured the attention of the field and was nominated for the prestigious International BCI Award in 2021. Application of brain-computer interface based on visuomotor transformation to controlling neurorehabilitation robot and transcutaneous spinal cord stimulation takes center stage as we explore its all-expiring journey. Join us as we dive into the captivating story behind this trailblazing project, guided by our esteemed guests. And we have 4 guests joining us today. Dr. Igor Lavrov, an assistant professor in the Department of Neurology and Biomedical Engineering at Mayo Clinic. Dr. Mikhail Lebedev, a leading figure in neurophysiology and brain-computer interfaces. Dr. Carlos Cuellar, a forward-thinking scientist driving innovations in neurotechnologies. And Ilia Borishchev, a visionary spacecraft engineer turned entrepreneur. Together, we will unravel the inspirations, exceptional contributions, innovative approaches, and transformative impact of this project. Get ready to embark on extraordinary exploration into the realm of neurorehabilitation, brain-computer interfaces, and the limitless possibilities they offer. But that's not all. Our esteemed guests will also share their invaluable insights on career development in neurotechnologies and provide expert tips for successful project submissions to the BCI Award. Let's welcome Igor, Mikhail, Carlos, and Ilya. Thank you so much for joining us today. It's a great pleasure and honor to have you on our BCI Award podcast series. I would like each of you to briefly introduce yourself and tell our listeners how did you join this field of BCIs and neurotechnologies? Because as I know, each of you joined this field from different area of work, different area of studies. So who would like to start the introduction?
Yeah, thank you so much for the invitation. It's a big pleasure to be here and discuss today. So I'm Igor Lavrov. I MD PhD. I have a dual background in neurology and in neuroscience. My primary position right now is Department of Neurology in Mayo Clinic. And just to briefly kind of introduce how I came to this specific field, or I'll say combination of fields, right? This came pretty much by collaboration with all colleagues who are here on the call. And I really appreciate that Mikhail, Ilya, Carlos was able to join and found time to share the experience. I think it's going to be an incredible experience for everyone, that we can cover different questions from different sides. And I guess in terms of idea development, it's probably was natural path, because definitely those technologies related to BCI, neuromodulation, closed open loop, etc., they can naturally follow and have to cross each other, right? And there are some points where they cross each other and we come to the new technological solution. So it's just a matter of time when we come to the spot. And I guess it's how it happened with us. We've been collaborating with Carlos for many years, with Mikhail, with Ilya for a few years, and then because we all have different type of background and expertise, it was natural path to find those connections and decide, okay, we have to do something exactly in the spot. And I would say, for me, it was clear that like BCI could help to extract some signals and help to control robotic devices or some stimulators, right? And I think everyone know great examples how BCI can control different type of devices, and how VR can help to train with BCI, with REAP, etc., right? And I guess the key part was how to interact between all those components, adding additional impact on facilitation of different part of central nervous system. For me, specifically, was interesting to learn how we can replace not direct communication from cortex to the muscles, but how we can facilitate those neurons in between and improve overall function. And this is what we're doing in the lab and clinic, and I think this is what we're trying to do in this collaboration.
Thank you so much, Igor. Mikhail Lebedev.
Yes, my name is Mikhail Lebedev. My undergraduate degree was in physics, but I never did physics per se. So it was more like biophysics, and I started with doing some research in human motor control. But then I wanted sort of more direct access to the brain, so that's why I got involved in neurophysiology studies in awake behaving monkeys. Yeah, this was in the United States, so I continued with this for some time till the field of brain-computer interfaces started to emerge at the very end of the last century. So then I was doing this for some time, also with monkeys, because monkeys are a great model for BCIs. And we did all kind of BCIs, which are relevant to the work we do now. And then later I shifted more to practical approaches, to neurorehabilitation approaches, and this is what I'm doing now. Currently, I'm a professor at Moscow State University. And so the key to this, of course, to have great friends, like the people who are here, and they have great expertise, and this is why we can formulate really multidisciplinary projects, because to rehabilitate devastating conditions like stroke or spinal cord injury, you really need approach that has many parts. Like one person with one type of expertise cannot do this. So my expertise is more like in extracting information from the brain, stimulating the brain. But then I'm sure Ilya will tell you how to add robotics to this. So as we describe our project, you will understand this better.
Yes, thank you so much, Mikhail. So we have already two fields merging together, Igor from neurology, Mikhail from neurophysiology. And of course, the work that Mikhail did is already a classic and can be found in textbooks, which I noticed even teaching undergraduates. So, the basic concepts that we are learning are coming from his work. And it's amazing to have you on our podcast. Thank you. And now a very unusual combination. Yes, Ilia Borishchev is coming from the field of aerospace engineering. So please tell us your story now. How did you join this field?
Yes, thanks, Milena. You are 100% right. And I normally introduce myself as a rocket scientist because what we do is definitely not a rocket science. It's way easier. It's just a joke. But yes, I was graduated from the aerospace university about 30 years ago. But the story is I never worked in, luckily, I never worked in aerospace industry. And I started my first enterprise being an university student, actually. And since then, for about more than 30 years, I'm just bossing people who do the right job, and I have no idea how they do that. I just tell them what I want them to do. So I'm kidding, of course, but it's very good thing to work with people who are way smarter than you, and to see that together you can move something forward. You can develop new technology. You can even help science at some point. And actually, my career was a series of high-tech startups. Mostly it was software development, corporate software development, and had nothing with neuroscience at all. But it was 10 years ago when I just occasionally became interested in brain-computer interfacing, and we started to explore how it works, how it can be applied in real life. And we started a small team. We started to develop new skills in this team. And after I moved to Canada 7 years ago, I focused 99% of my efforts on the development of the project that we called VIBRAINT Rehab, which is a brain-controlled rehabilitation robot. And in this exciting journey, I met many great people, starting from Mikhail. The story was we organized an annual brain-computer interface conference, and Mikhail, one of the first foreign speakers on this conference, and this is how we met back in 2015 or 16. So this is how I entered the neuroscience field, and this is what brought me here to have such an honor to speak with these great people in this room.
Yes, absolutely. That's such a great example. The whole your group of how people from different areas can join together and create amazing project together. Thank you so much, Ilya. And now, Carlos Cuellar. Yes, we want to hear from you now.
Thank you, Milena. Thank you for having us. I'm really excited to share with you our experience and in this field. Where my background is in biomedicine, that is a combination between medicine and biology. And I did my PhD in cellular and molecular biology. So I always been interested in how the brain, how the body can control movement. So I always been interested in movement. And I have experience in many animal models trying to understand how the small circuits in the spinal cord can coordinate complex movements, for instance, when we are walking, when we are breathing or whatsoever. So I have a very good opportunity to be in Mayo Clinic a few years ago. And actually, Igor was my supervisor. It was an excellent team. I have very good experiences and moments and memories from that some years ago, actually. And we did some experiments in animals. And when I came back to Mexico, I was very interested to start with these projects in human with a spinal cord injury. And we're going to talk about this later. But here in Mexico, I'm working at Anáhuac University. I teach some courses in different programs, master and PhD programs. But I've been doing research. That's my passion is neuroscience. So in this project, I'm very, very excited to start with this combination of different expertises. And yeah, we will to discuss about some interesting results with our patients, and also this very important idea to combine two different approaches that we know that work very well. So combining BCI and spinal cord stimulation is going to be a tremendous journey. So yeah, we're excited to combine the thoughts here today.
Thank you so much, Carlos. And I think we built a momentum now to tell our listeners about the project itself. What is the project about and what were the main goals of this project? Igor, please.
Thank you. Well, first of all, this project would be happen without interaction we had between all of us, all four of us, and primary in conversation with Mikhail and Ilia came to this kind of direction. And I think Ilia was definitely driving force for all of us. Like he mentioned, he was pushing us to go somewhere and get something and apply somewhere, right? So I guess it will not be possible at all because we can't always focus on multiple tasks. And in terms of idea, again, I think it was clear that all different backgrounds we have to. Some moment we have to focus on combination of BCI robotic devices, virtual reality, and neuromodulation. So I think, like for many other teams, there are many groups who trying to focus on this. Right? It's not like unique situation. It's a very intuitive question. The key question here: what may work, what may not work, right? And what we really focus on. Because again, I think from my end, I'm not a BCI person, and it's for me first time when I'm kind of collaborating with experts in BCI. So again, from my end, I kind of feel that there is key gaps in application of BCI because by BCI, I understand that we're trying to replace something that goes from the cortex all the way down to motor neurons or to muscles, right? But from neuroscience standpoint, it's not like we act, it's not like we behave in real life. Because in real life, we don't really think much about how we control most of our movements. When we walk, we don't think about this. When we write, we don't think about how we write. We're trying to express our thoughts and it just goes, right? We think about specific movements when we learn, right? When we learn new task. We think about specific movements when it's very critical to provide very accurate control. And we also think about movements when we have clinical problems like spinal cord injury, stroke, etc. So in those cases, patients, like after stroke, they have to be very focused on each small movement, right? So it's a totally different approach. So again, the BCI, the way I understand right now, can help to make this kind of big bridge, like across multiple areas in the central nervous system. So when we introduced neuromodulation to treat spinal cord injury, like initial thought that we just going to be stimulating spinal cord to facilitate repeat movements, which are going to be totally without volitional control. Because we already knew that most of animals and humans as well have so-called CPG, central pattern generator, right? And we've been playing with different ways how to activate it, with electrodes, with pharmacology, and different techniques. But the key excitement, and kind of discovery happened when patients that had been completely paralyzed became able with stimulation to control movements. So not just rhythmically produce some patterns, right, without control from the brain, but they became able to actually volitionally initiate, terminate, or adjust those rhythmic movements, and then control specific movements and joints. This was quite impressive to see something that was totally unexpected. And again, this goes very below the cortex, right? And the current concept that we facilitating certain circuitry in spinal cord, which helps to amplify signals that we receive from the brain using just a few spared fibers cross injury. And those signals became able to control the circuitry when we stimulate the circuitry. So it's a kind of amplification effect. So again, but this goes in between what we're trying to connect with BCI. So the idea was, okay, if you go this direction, to what extent we can first of all replace this precise cortically driven movements It's kind of first obvious question. And second question, to what extent we can facilitate other parts of CNS to improve natural movements and natural control? So I think those questions still open. It's just the matter of how fast we go in this direction.
Okay, thank you so much, Igor. And Mikhail, maybe you can be the second to tell our listeners about this project, and maybe in terms of how was this particular project different from what has been done before? So what was the main innovation of this project?
Yeah, the core of this project is a brain-computer interface. And if you think about what a brain-computer interface is a kind of futuristic idea that you connect the brain, stick some sensors in the brain, record activity, then decode, and then you connect it to some external device. So it could be, say, a prosthetic. And then a fantastic thing happens that you modulate your brain neurons, and this way you connect them to this prosthetic arm and it starts to move. Or it could start to feel, say, if it has sensors and it touches different objects, and then you send the signals from the centers back to the brain where you evoke artificial somatosensory sensation. In addition to these fantastic goals, the field has very clear practical goals, which are medical. So, and all over the world, there are millions of people, patients, who need help to improve their rehabilitation. And here it was kind of clear that brain-computer interfaces could help somehow, but it was not very clear how they could help. And even if you read more recent reviews about brain-computer interfaces in rehabilitation practice, then you see that they do not explain clearly why you need these interfaces, why you need all this decode, transform, move something with your brain. Why does it help to rehabilitate? Yeah, and here our idea is that we need to go back to the very key principle of brain plasticity, which is habit plasticity, that you need to synchronize some kind of activity in the brain with the inputs that come to this brain. So in the case of neurological damage or neurological injury, you have some area of the brain that could be damaged, or some other parts of the brain are still active. So, and you need to reconnect them. So this is why it is critical to be able to record from the areas of the brain where the activity is still good, and then synchronize it to some additional inputs. So this is exactly what we do, and we call it a brain-computer interface for visuomotor transformation, because the majority of movements that happen with us are in the visual world. So you have a visual object, and then you direct your movement to this object. So just I get a cup of coffee. So sounds simple, but it is not as simple as it sounds, because first I need to direct my eyes to this cup of coffee, then encode the image in retinotopic coordinates, then it goes to a different part of the brain where it gets encoded in room coordinates, and then finally I need to perform this movement. And now the coordinates are muscle coordinates. So a very complex transformation, and it appears that many areas of the brain are active to perform this transformation. So this is good to study for basic research, but when you come to neurological conditions like stroke, then the problem is that this visuomotor transformation is damaged. So a person can see an object, but somewhere this link from the visual representation to the motor activity that enacts the movement is damaged. So our goal is exactly to restore this visuomotor transformation loop, and this is why, and then we will go into the details of this later. This is why we use all kind of activity, including responses to visual information. to try to reignite this visuomotor transformation loop. And also we use spinal cord stimulation as an additional facilitatory factor. So this is our project in brief.
Thank you so much, Mikhail. And now, like you said, there is the next step of really reigniting that loop, the practical part of it. Carlos, would you like to tell more about that step?
Yeah, sure. Yeah, so right now we are running a trial in patients in Mexico with spinal cord injury. And we are using this neuromodulation approach. That is something, the idea is quite simple, is to provide electrical current through the skin, and all the electrical current is going to the spinal cord and somehow is providing more excitation or more facilitates movements, right? Rhythmic movements. But most of the patients, they have also issues with upper limbs. And for them, it's very important to have nice control of movements because they cannot use a cell phone, for instance. And we are very interested in this approach, combining BCI, robotic arm, and spinal cord stimulation, because the patients want to improve some of the fine skills that are very important in their daily lives. So yes, this idea is very exciting because so far we are providing just rehabilitation through rhythmic movements, some passive movements through physical therapy. But I think with BCI, we can expect to have more involvement with the brain and provide some plasticity. As Mikhail and Igor mentioned, there are many open questions, but hopefully we can improve motor skills in upper limbs in our patients. So so this general idea, this project is very exciting because we can provide some specific improvement in our patients. So I think this is a natural next level in this project to improve motor skills, not only force or grip or some rhythmic movements, but also some fine skills in upper limb.
Mm-hmm. Thank you so much, Carlos. And for our listeners to really understand how the things are going on, can you maybe describe a typical experiment in your lab where you are doing this study? Let's say one day of a person doing the experiments. How would it look like? From him entering the lab or, somebody bringing him or her into the lab and then, what is going on?
Yeah, sure. So at the beginning, we have to make sure that the patient covers some inclusion criteria. But after that, we have to get baseline data and we have to do some clinical tests. We have to see if there is some spastic movements or if there is how the paralysis is involving upper limbs, lower limbs. And after that, we have to be very careful trying to apply electrical current. We're going step by step so that once the patient is used to the current, we have to record signals from muscles to see if the electrical current is actually activating those muscles. So after that, we have a standard protocol used in many labs. So we apply current, and at the same time, we are doing physical therapy, specifically for lumbar segments, meaning that we are now focusing on lower limbs, trunk control, because some patients, they have very bad trunk control. So right now we are focused on trunk control, reducing spasticity, maybe getting more rhythmic movements in lower limbs. But interestingly, there's some also improvements in autonomic function. So that's something that is interesting at this moment. So usually we have sessions of about 1 hour. So for each patient, twice a week, or maybe in some cases just once a week, depending on the patient. And the protocol lasts for over 2 months. So we have baseline data, and after 2 months, we have to get more information about the improvements in motor function, autonomic function, trunk control. And we are focusing now in lumbar spinal cord segments, but we know that it's very important to have control in upper limbs. So that's a typical day in our life. So we have to provide physical therapy for those patients, and at the same time we are applying spinal cord stimulation.
Thank you so much, Carlos. And now, Ilya, as you are the main engine, yes, that is pushing the project, can you tell maybe what are the main challenges that are coming up during this multifaceted project with multiple people involved, and how do you help or facilitate solving those challenges?
Thanks, Milena. I wouldn't say I'm a main engine in this project, but my job is just to organize like stuff, which is probably the simplest part. And the main engine is the motor. And there are at least 3 motors who are sitting like in front of you now, and I'm just like a pedal or something like that. But speaking of challenges, there is a lot of challenges, of course, and probably the most common challenge in neuroscience, in every science, is the great unknown, because you never know whether your idea is gonna work, and you probably have to spend months or years to understand that you are just going in the wrong direction. For me, with my engineering mindset, it's very hard to keep patience, because people sitting in front of you, they are scientists, and their job is to explore. Whether it works or not, their job is to bring knowledge. Whether it's useful, it doesn't matter to them. I'm kidding a little bit or exaggerate, but you understand what I'm talking about. And my approach is, I'm from the business side of the things. I would like to bring something, say, to the market, to help people, to bring it to the clinic, to bring it to the patient. And I would like to make it faster. This approach just doesn't work in neuroscience, because you must be careful, you must be precise, you must be 100% sure that it's true before moving forward. This is, again, the general challenge in neuroscience, in neurorehabilitation, in everything related to neurophysiology, to humans, because it's about their safety. Another thing is, it's always a problem of like different people have different approaches, different people have different goals, and sometimes we have long discussions on where we want to go and when should we try this and why should we try that. And takes us time to put things together and to decide where we are really going, what we are really going to have, and how to do it most efficient way. This is from the organizing side of the project. Also, funding is always a problem, because, for example, we are sitting here, everyone is in another country, and how to get someone to fund the project, which is not related to this specific laboratory in this specific university, is always a challenge. Another thing is, first, we started this project actually in 2020. And you remember it was COVID time. It was not easy to manage things during the lockdown, especially because we need patients. And everything was locked down, and we just had no access to patients for long months. Now we have the war that is like it changed COVID and war in Ukraine. It changed the world totally. We are now living in a different world, and like not every, but many connections are broken. We cannot continue some project. We cannot continue some activities due to different reasons. We experience problems with technology. For example, we need some specific chip which used to cost $30 and can be bought right off the shelf for like in the store next door. Now we have to order it from somewhere and wait for 6 months and pay 10 times more for the same like piece of metal and plastic. So this is a challenge as well, because it costs us time, which is the most precious matter in every project. So I would say these are the biggest challenges from my perspective. I would also say that what helped us to continue is that everyone in this project would like to continue this project. So we just have no choice other than find a solution for every problem we meet.
Yeah, thank you so much, Ilya, and also for acknowledging all the challenges, because often we talk about projects and how good they are, but behind there is so much work and so much problem solving. So thank you. Igor, now as we already talked about the project itself, about the main aims and goals, would you like to tell our listeners about the results, at least, the main results of the project? And especially, I'm very curious about that volitional control. What did you find?
Yeah, thank you. Yeah. Well, so I definitely want to acknowledge what Ilya said. It's I think, very important, and to some extent, it's impacts our work and what we've been able to achieve since 2020, right? I guess it was a period when COVID was impacting our capacity to recruit patients and move forward. Then I think it was a period when COVID actually helped us to set up multiple communications across different countries, and it was much easier to communicate between all of us, and maybe even easier to distribute different activities between countries. And then it was definitely a period when we started to see kind of transformation from economically driven development of technology, like based on cheapest device and cheapest logistics, right, to politically driven, right? Because I think right now you see more and more examples where economical factor is not the first. And of course, now it's much easier for governments to sell political agenda, because security is the issue, probably number one, right? And then we come with something future that we want to expand and improve. So again, I think we kind in a different world in some extent. On the other hand, maybe like 100 years back, it will help us to consolidate the current knowledge and move it more specifically to practical application. And so again, we've been able to collect different set of data between all of us, between all spots we have at the moment. And most important, we've been able to connect all parts of this complex study together, at least in a few places, and been able to initiate some pilot studies where robotically driven rehab help patients to control upper limbs, patients with stroke, patients with spinal-cord injury. And then those patients been able to learn how to use brain-machine interface to control these robotic arms. And then those patients being also stimulated to facilitate some level of volitional control, which they could improve with, in addition, Spinal-Cord Stimulation. So for all those studies so far, we used a non-invasive approach, but there's definitely potential to use more invasive technology when put electrodes on the spinal cord. And maybe just to explain how it goes historically. So like Ilya mentioned, there are a line of challenges, and one the challenge we always have with neuromodulation is specificity, how specific we are with facilitating certain function. I guess same question we have with BCI, right? Like years back when I was working at UCLA, my colleague Paragat came to idea to actually use AMG signals from forelimbs in paralyzed rats to see when forelimbs start to work. So he was able to develop simple software that record rhythmic EMG activity and start stimulator. So basically, stimulator send pulses below the injury at the lumbar level. So hind limbs start to work as well. So basically, whenever rats start to work with forelimbs, it starts stimulation on lumbar segments, and it starts to facilitate hind limbs to work, right? Again, it's very non-specific. It's kind of very general, taking signal from upper limbs, sending just to turning on stimulation below the injury. It's very non-specific, right? But when we implanted electrodes to first subjects with complete paralysis, I think already on the first subject, we found that we can actually orient current. We can move current to the right or left side. And if you move current or orient current to the left side, this patient is able to control his left leg. So basically, he's able to volitionally initiate movements in left leg, but not right, and vice versa. When you move electrical field to the right side, he's able to control right leg, but not the left. again, this adds a little bit more specificity, right? And then we did very extensive studies with Carlos here at Mayo on peak model. We started with peak model because spinal cord in peak is very close to human in terms of orientation of dorsal roots, ventral roots, spacing between roots. We don't see it in rats at all, so we need to move to kind of large animal. And then we found that actually, if you move electrode across midline, it's very different response when we put electrode on top of the roots or between the roots. It's kind of very, very simple observation, but it was quite surprised for many colleagues I saw this moment, and they didn't expect that this could be so different in terms of motor response. And then we realized that orientation of roots is quite different across different segments in a swine model. So we did precise evaluation of how they orient and how we need apply current so we can provide the best activation. And then we realized that there is no such data in human. So we went to cadaver lab and we did very long, very extensive studies to measure specific human anatomy. And this study could be done 100 years back. Because there is no rocket science here. It's just you just go to cadaver lab, you open spinal cord, and you take a ruler and you measure. So again, this can help us to think about segment-specific stimulation and to feature optimize this approach. So again, there are a lot of options to improve it further. But for this specific study, we so far we focus on non-invasive stimulation. And this is not that specific, right? So we basically activating right or left side at the same time to help patient generally facilitate some level of motor control. So again, I think that the fact that all those companies been combined together and facilitated this initial state of this project, I think this is quite important. So it's where we are in terms of this study. We still have line of questions, like to what extent we can improve function, to what extent actually patients can learn how to control their motor functions without stimulation. I definitely see a lot of questions on BCI side, and maybe Mikhail can elaborate on this, like a lot of questions about noise when we combine stimulation and recording from cortex, especially with non-invasive BCI, right? Yeah, so definitely there are many questions still open, and we have to find optimal solutions.
Thank you so much, Igor. And as you suggested, I would like our listeners to hear from Mikhail. And Mikhail, maybe you also can elaborate more on the visual motor transformation loop. What were the findings and any additional findings that Igor didn't mention, maybe you also can mention. Then we will talk more about the challenges. I also would like to hear from you about the challenges, specifically already with the BCI, with the experiments, with the data analysis, and how you overcame those.
Yes. So if you look at the current approaches to rehabilitation with BCIs, so first of all, the majority of them are non-invasive. So because we are simply not ready to stick electrodes in some patient with a stroke, say, to help to improve his conditions. I'm not saying that in the future this wouldn't be the main approach, but right now it is non-invasive. So now we deal with things like EEG in most cases as a way to get activity from the cortex. And then we have just limited number of BCI designs that could be used in rehabilitation. So there are just three of them. So the first one is motor imagery based. Or it could be like sensory imagery or some variation of imagery, but imagery. So you ask a subject to imagine something. Then, this is, by the way, the major approach in rehabilitation. So, 90% of the works on rehabilitation are motor imagery. So they ask a stroke patient, please imagine the movement of the arm. We'll record some kind of EEG activity and extract these signals, and then you use them to improve you. So this is very good. Yeah, actually we have very good examples of success. So it worked great. They showed that the patients were improving. And so this was definitely a success. But what we thought that something was missing in this. So, and this component was the good use of visual signal. So, and now we come to the second type of BCI, and it is exogenous BCI, externally driven. When you give some external stimulus and it drives your brain activity, and then you use this for to control BCI or for communication. And the typical example is the P300 interface. So a subject is looking at the screen and some letters are flashing on the screen, and then you ask to pay attention. Let's say A. You look at the A, and then you extract this A from the brain. So this is called the BCI speller, and you can read about it in many studies. But now our idea, or I would say Ilya's idea, was to use this kind of interface for rehabilitation. And the idea is that instead of encoding a letter of the alphabet, you decode the location of a target of movement. So in the interface that Ilya suggested, there are several targets, each of them flashes, and then the subject directs his attention to one of them, and the interface works like a P300 interface, but the meaning is different compared to the usual way it is used. So now it is a motor target. So you immediately try to reactivate this loop of visual motor transformation. And then after this P300 interface worked, then you add a robot which moves the subject's arm, and now you restore voluntary movement. So from the decoding of a motor target to a robotically assisted movement. So this is the way to restore this voluntary control in a patient suffering from stroke, or even for spinal cord patients. This works as well. So basically, this is the idea. It is not like it worked immediately. So some more work had to put in this, but eventually it worked. And now we see that in many patients, this really helps. Patients are really engaged in this. Yeah, there are also ways to improve this. So hopefully in the future, we will show even better systems that work faster and more efficient.
Thank you so much, Mikhail. And now, Carlos, now I have a question for you. What do you think became possible with this project, with the results that you currently have that wasn't available before? What are those results that will help to propel the field forward, to bring new approaches to rehabilitation, to how we work with patients?
Yeah, that's a difficult question. So I would like to say that my expertise basically is in animal studies. And, as a scientist, you want to simplify everything. You want to control all your variables. And then when I became involved in this project with patients, that's a totally different story, because the patient, they have different aims, different objectives. Some of them, they don't know if this is going to work. And of course, they have great expectations sometimes about these projects. And spinal cord injury is a severe condition. In some patients, they can move some muscles, but some patients, they are completely paralyzed. Okay, so I think the main challenge here is to deal with these differences between patients, because you want to get in your experiments in the lab, you get nice responses. You can compare between animals. Okay, you can have your average and so on, but in the patients, it's a completely different story. And of course, sometimes you have to deal with if the patient is happy some days, some days the patient is not able to practice, to do exercise, to do physical therapy. So I think that's a main challenge in this protocol. And obviously, there are many questions because some patients, they have these improvements in some weeks, maybe after just a few weeks. And for some patients, they are more slow in a slow path. So it's different for each patient. But we are confident because we are replicating studies from different labs in the US, in Europe, in different countries. So at this point, we know that transcutaneous spinal cord stimulation, if even is a non-invasive strategy, is not very specific for stimulation in the brain. The patients are getting improvements in many areas. So at this point, I think we are confident. In Mexico, we have a very good physical therapy department. Also, there are many students involved in this project, very interested in BCI, very interested in neuroscience. So with all this expertise and many people involved, I think we are confident that we can get at least some improvements. And also, there's one challenge here because after many years of spinal cord injury, some of our patients, they have more than 20 years after spinal cord injury. So another problem is when they are in the lab, in the physical therapy facilities, you ask to the patient, okay, try to move your right leg or your left leg. And they have to think about that. For us, it's very natural to do some volitional movements or to walk or whatever. But for them, after many years, I think in the brain, there's something different and it's more difficult for them, not only because of many complications, but also because there is some rewiring in the brain and it's difficult for them how to control just basic movements. So yes, it's not going to be easy. There are many open questions, and this also we have to learn about the patients. We have to learn about different labs, and we have to learn day by day, week by week, how the patients are trying to control BCIs. Some of them, they are not familiar with BCI, with all this technology. And but yes, I think at the end, with combination of these strategies, spinal cord stimulation, robotic device, and BCI, hopefully we can get results for the patients. So yeah, I think it's a very good opportunity. And yes, we are confident because we have all this great team involved.
Thank you so much, Carlos. And you, the eye of the team on the practical part of things. So you might have a good vision of how you want this final product to look like. Maybe you can share, that your ideal product, how it will look, what opportunities will it provide to people, and, how far are you still from that ideal goal, and, maybe some steps that you think will be necessary to get there.
So my vision of the ideal product is like small or medium-sized green button. We just push it and it changes the patient state, and the patient begins to control their arm or to walk or whatever it is. But we are moving very slowly in this direction. And so far, our product, the technology that we use in this project is robot for upper limb. It was quite complex from the beginning. We already simplified it and made it a tabletop to allow use in literally every settings to not be bulky, because many labs, many clinics, they experience lack of free space to keep and to use the bulky equipment. Basically, it's a robot. It's an EEG device, and we are now moving from using the medical grade device to our own homemade one, which is supposed to be smaller, easier to use, more friendly. It will be wireless, which means a lot from the FDA perspective, because wireless devices are supposed to be more safe. I can say the same thing about the robot. So the initial robot was all wired. Now it's all wireless. And we started with the robot that just was able to move the whole limb, the whole arm. Now it also controls the wrist movement, and we are going to have the simple hand exoskeleton to allow rehabilitation of more skills than it was initially. And we would like to have the BCI control to be able to work with the dry device, which is a big challenge because now we use a wet EEG, and for many clinicians it would be an obstacle because they don't like to spend their time on taking the electrodes, putting the gel in, and they would like just to put some like simple headset on the patient head and to get it working in a minute, which is our dream as well. And we go in this direction too. Also, we think about the original robotic device for lower limbs because we are in our conversation, we jump from upper to lower limbs, and now our solution only allows upper limbs rehabilitation, and lower limbs is a little bit different story. And from my perspective, it's more complex. It's complex because of neurophysiology, and it's also complex because of robotic technology, because the limbs movement are different from the lower limbs, different from upper limbs. And this is another direction to think of and to move forward. Also, our solution, now we are in the study stage, and it requires professional attendance, a researcher or a clinician. But our target population is not very mobile, and it's hard to many of them to reach the laboratory, the clinic, and our device can be brought to homes, but it still needs doctors' attendance. And our goal is in about 5 years to develop a solution allowing telerehabilitation. So we still have a doctor, but on the other end of the wire. And it will simplify things for patients, and with the help of their caregivers or family members, they would be able to exercise at homes. This is probably the biggest step to the red or green button, which can be just pressed and fix all the patient's problems.
Thank you so much, Ilya. And of course, I wish you to find that green button, to create that green button, and everything will become so much easier. Thank you. And Igor, I would like to ask you to provide our listeners some perspective on the current state of rehabilitation for spinal cord injury. What are the current approaches, and how this product that Ilya described, how it will be different compared with the current state? Yes, what advantages would it provide to patients and caregivers and families?
Thank you for the question. It's a great question to discuss. Maybe I can start with what Ilya said about last point, where this concept, this device would move to more integrated approach with remote patient monitoring and interaction. And I think this is one of the key points that we're still missing. Especially it became obvious in the COVID time when especially rehab patients, they couldn't access the facility. And as you know, in a rehab facility, you have 2-3 therapists working with one subject, right? And basically it was time when people can't be in the room more than certain number, right? So it was really impacting the whole process. I think another key point that in pretty much all countries, we have clear limitation on time that patient can receive rehab in clinical facility based on insurance policy, right? There's some difference. Like in Australia, it's quite more time you can offer patients compared to US. There are some countries where it's like just 2 weeks. There are some countries where it maybe like a month or 2 months. It's really a difference between policies, but it's still quite limited. So I think, and even within this time frame, we still can optimize time that patient dedicate to training, to improvement. Like some patients would be, maybe all patients would be happy to train themselves all the time, right? Or at least to use most of the time they spend at home or somewhere else outside of clinical facility. And there are multiple options to improve it with remote patient monitoring, with some devices which help to actually facilitate movements like neuromodulation, especially for those patients who are completely paralyzed. They can't really do anything without stimulation. And those patients who receive implants, for example, they can start rehab at home. So basically they turn the stimulator on and they can do movements. But the question how they do it, right? They need special support for at least one leg or for the whole body, and they need to follow certain command. They need to keep certain level of protection so they will not fall, etc. Right? So again, there are a lot of questions how to optimize time, and I think it's one of the biggest challenges. On one end, it's quite obvious, but on the other end, a lot of minor improvements could help. And why it's important in terms of this project, because we're actually using different components, right? BCI robots, yes, neuromodulation, and they all could protect patient in some extent to help him optimize level of control and improve flexibility of motor control and basically provide best rehabilitation. So definitely we need to think about how to move this approach to be more user-friendly and be applicable in a home environment. So I guess it's one direction. When we talk about spinal cord injury field overall, I think there are some challenges related to negative experience. I mean, negative experience based on research conducted without clear impact on the field. For example, multiple labs been working on different type of regenerative therapies for decades, and a lot of great results and paper published on rodent studies. But whenever those data been translated to clinical facilities, to clinical trials, they show no impact. And because of this, there is an opinion that it may not work at all. And you need to come with something entirely new to convince, for example, reviewers to fund the study, right? But it's not really true, because right now we see great examples when, for example, integration of regenerative therapy with stimulation helps to improve impact of stimulation. Like a simple study we conducted with Carls years back at Mayo, we, in collaboration with a local team, Dr. Winterbank and other colleagues, we implanted scaffolds in the spinal cord and grew new fibers across scaffolds basically after complete transaction. And what was surprising to us, those new fibers, they can improve the effect of stimulation to facilitate stepping and those threats. So again, there are definitely clear evidence that when we combine those therapies together, we can improve outcome, even after anatomically complete injury when we grow new fibers. And we conducted also line of studies on pigs, where we combine different type of cell therapies and stimulation. We found that there is some benefits to integrating both therapies. So again, I think this definitely could be another direction in this field where we need to focus on potential benefits from both therapies when they combine together. But in the same time, there is kind of a negative experience. So we need to kind of explain step by step why what we are doing now is different from what was done in the past. Even to some extent, it may look close. So I think this is kind of a challenge and also future direction. I think another key question is data set, because when we talk about this type of studies, there are just a few groups who are doing this, and overall, I think we need much more data to inform future steps. And this needs to be more open, I guess, the communication between different teams, between different groups to exchange data and discuss where they go. And we definitely have some technological limitations. Again, we always talk about biocompatibility, about integration for BCI, for electrodes. It's quite many teams working on those questions. But at the same time, I guess we still have conceptual limitations, and those conceptual limitations, especially clear when we do some work in between fields, like between BCI and spinal cord injury and neuromodulation. Like again, like I mentioned earlier, based on what I learned from Mikhail works and from other colleagues, we can decode very clear signal from the brain related to rhythmic pattern, like stepping, right? But it doesn't mean when we stimulate those areas, we can facilitate this pattern. Like another good example from clinic, patients with seizures, sometimes they produce some rhythmic movements like chewing or leg movements like in bicycle movement, right? And you can record from EEG those patterns. You see them clearly. But when you stimulate those areas, you can't produce same patterns because those areas connected functionally with in other areas in the brainstem related to chewing or in spinal cord related to stepping, right? So again, we may need to think, again, it's probably too early to say how and where, but we may need to think about not just brain-computer interface, but also spinal cord computer interface and maybe brainstem computer interface. And those questions may be not trivial at the moment, but definitely there are a lot of opportunities on that end. That's potential directions where we may go.
Thank you so much, Igor. I liked how you provided this broad perspective for the field and its potential growth and possible combinations with other fields and other approaches, which is important to think about, and also to remember that everything is not as straightforward as it might look like. Yes, we may not be able to stimulate and receive the same response as would want it. There are many structures involved in these complex behaviors, complex processes, and we may need to think about all of them, not just about one. Thank you so much. And in terms of that, I would like to ask Mikhail. Mikhail, maybe you can talk about the new technological developments and innovations in science, in technology that inspire you. And what do you think might be those fields that can contribute to this particular field of rehabilitation for spinal cord injury, for stroke, that may become an important part of this process in the future?
When we talk about new technologies in this field, people usually start to talk about Elon Musk. Like Elon Musk will now solve all the problems in the neuroscience and neurorehabilitation and everything, defend us from artificial intelligence. But surprisingly, even though Elon Musk has much more money than any of us, then what he is currently doing is he's just repeating the demonstrations that we had like 15 years ago. He showed the monkey that plays Pong. So we did this even wirelessly. Or he had this pig walk on a treadmill, reconstructed walking patterns. And again, we had the monkey walking on a treadmill. What else? He's now talking about his visual restoration, also not completely new. And actually, this is a very extensively developing field. But still, even though that people like Musk and other companies, businesses that are engaged in this field, they don't have like many new ideas, but the technologies that they are developing, new technologies, are really good. So in Musk's case, he has very small devices that he implants, and many channels, like thousands or maybe tens of thousands in the near future. And there are ways to record, ways to stimulate. And other people propose many more new technologies like neural lace, neural dust, nanoparticles. So all these at some point will introduce very new ideas how we deal with all these medical problems of neurorehabilitation, etc. But not yet. So right now it is clear that this is all developing and it will have a very huge impact. But right now we are still working with some traditional approaches. And I think this is perfectly fine because even with these like simple ways to deal with interfacing to the brain and neurostimulation, we still have many problems to solve. So hopefully, how I think this will develop We will continue what we are doing now, so we will be achieving more and more and more and more progress. And then these new technologies at some point will spike, and then at this point of intersection, we will do new stuff where we introduce new cool ways to record from the brain or stimulate different parts of the neural circuit area specifically, etc., etc. So overall, I think the future is pretty bright. So, and any person involved in this process is doing a really important work.
Thank you so much, Mikhail. And in terms of people involved, Carlos, you mentioned that you have many students working with you. And actually, there are many students listening to this podcast. Can you share with our listeners how students can contribute to this fairly complex type of work, what they can do, how they can contribute, and maybe use some examples from your lab? What do students do and how do they contribute to this project? And what do they learn in the process?
Well, first of all, I love the energy from students when they are going to physical therapy facilities or in the lab. They have many questions. They want to learn. And this is very exciting because some of their questions are very sharp, very, very clear. And I will say most of the time, I don't have the answer. So that's very, very important for all the people involved to get involved and to participate with different questions. Basic questions or complex questions is very important. And we have students from different backgrounds. We have medical students, we have physical therapy students, engineers, and at some point it's very interesting to see how they are involved, how they interact between each other. They think that a medical student is going to be in the hospital the whole time, but it's very, very interesting when they have this interaction with engineers. So engineers, they have a very different perspective, and all the environment is enriched in many ways. And it's also important for physical therapy. So for example, for physical therapy students, they are sometimes they don't want to touch computers. They don't want to touch the equipment. They're afraid of this technology of electrical current, I would say. But at some point, they're more confident that they are working in the project, that they're interacting with patients. And for students, it's a great opportunity to learn a lot, not only about the central nervous system, but also about some parts of engineering, how to solve connectivity issues, how to solve many things. So we have some problems sometimes with technology. We have some problems with equipment. But students, they have to learn how to solve in the moment because the patient is there, okay? So we have to be very fast. So I think this complex project with many different approaches is challenging for students, but for sure they learn a lot. Sometimes they read a lot of papers and they know more than me sometimes. So this is very interesting. So I will say to all the students trying to pursue a career in neuroscience and engineering, to get extra efforts, it's worth it a lot. So for my students, I will say I'm very thankful to have a great team, to many have people involved, and also to collaborate with all these people. So yes, I think it's a very good opportunity for students. So don't be afraid to neuroscience. Don't be afraid to get knowledge from different backgrounds. So it's a great journey.
Mm-hmm. And what would be your recommendation for them to join the field, join the lab, get some experience? What is the best way to get into projects like this?
Well, I think most of the students are interested in the brain, in science in general, but they don't have a clear idea in some pathologies, or they want to do something, okay? Because sometimes they heard about stem cell, they heard about BCIs, and sometimes they're afraid to new technology. They use technology all the time, but at some point it's difficult to get involved in this project. So they are afraid at the beginning, But I will say, talk to scientists, talk to your professors, talk to people involved in the labs, read the papers. There are now many interesting podcasts like this. So I think this is a very good opportunity to be involved in science, to learn more about different approaches. And I think that's the first step. So there are many conferences, very interesting conferences in YouTube, in the media. So we have not only books, but people talking about this new technology, and we have many sources of information. So if you are really interested in science, in how to solve a problem in the brain, so just get involved, ask questions. I think that's the main advice from me.
Yeah, thank you so much, Carlos. And now the question for Ilia. Your career is somewhat unusual, yes, the way you joined Neurotechnologies, but it also gives you this different perspective of how people from different disciplines that might not be directly related to neuroscience, neurotechnologies, can contribute in a meaningful way to this field. So, what would be your recommendations for those who are in distinct fields, but they heard something about neurotechnology and they want to do something in this area? What would be your recommendation to join the field or to, make some contribution?
Thanks, Milena. I would start with the second part of your question. So, in my opinion, the most important thing in neuroscience and specifically in brain-computer interface is the thing we often forget because we consider it like it just exists, it just happens, but we often forget that actually BCIs, they don't exist without the human. So the human is the most important part of every BCI. Without a patient, without a subject, it doesn't work. Until you put yourself in your patient's shoes, you get nowhere. This is probably the most important that I learned because with my engineer background, I often was thinking about, say, BCIs this is a technology. We can just read some brain waves, recognize what happens inside, move some robot here, turn the stimulation device on, and that's it. It doesn't work like this. Carlos already mentioned it twice, and Mikhail and Igor of this program as well. So without patient-focused or subject-focused approach, it never works. So this is probably the biggest lesson I learned. If you are interested in a field and you are not in a field, how to get in. In my experience, it was easy because I just started to talk to people, to get information, to learn from them. And those who were interested in continuing, I just started to continue. So as I already mentioned, I met Mikhail. He introduced me to Igor. Igor introduced me to Carlos. So networking is everything. Don't be afraid to ask. Don't be afraid to communicate. Don't be afraid to look stupid. I'm still looking stupid speaking with the neuroscience professor, and I don't care about this because it doesn't matter. So if you are interested, be persistent and everything will come.
Yeah, thank you so much, Ilya. I think there is a common theme in between what Carlos was saying and Ilya. It's networking, it's communication. It's really a key to talk to people in the field and get perspective information from them. And of course, I absolutely agree that we always need to remember with whom we are working. Yes, that these are people for whom we are building this. Yes, that's the key. Thank you very much. And now I would like to talk to Igor and return back to the BCI Award where we started. Yes, that this project was actually nominated for BCI Award. Igor, maybe you can share with our listeners the journey to that award. What was important, you think, in your project submission for the award, and maybe some tips for our listeners, for those who are planning on submitting their project for the award, and maybe even not planning, but afraid to submit, thinking that maybe, my project is not good enough, like, some people sometimes think. Yes. So what would be your words of encouragement?
Thank you. Yeah, thank you. It's a difficult question because, I didn't do much for this award because it pretty much came from Ilya and Mikhail. They were encouraging to do something, and basically Ilya submitted this whole award. So all credit to them. So I have nothing to add. But I think I will try to add, like I said, for students, for colleagues. I think we all, if in science, right, by definition of science, we're trying to build new things, right? I mean, whatever you do in science is something new by definition, and it's never been done before. So otherwise, it's already something that you repeat. So, and again, if we in science field, we just do it. We just need to try. It may work, may not. I think what is really tricky and what is probably most important is not just to try new things, because there are so many new things, but to learn from people who already try their negative experience, because they don't publish negative experience, right? That's why collaborations and professors, it's very important to learn from them what do not do, what they already done. And another probably even more important part is how to build a right environment to try new things and to see new things happen, because the key success probably comes from that. And building right environment, building right collaboration is extremely difficult and takes years and a lot of waves and ups and downs. So I think this is one of the key. Otherwise, we're all doing science, we're all trying to try something new, right? I guess we always kind of trying to say that don't do my mistakes, do your mistakes, right? And I just thinking what type of mistakes. Well, definitely, like everyone already mentioned, maintain collaboration and learn from colleagues, because I was learning a lot from everyone in the school, from Mikhail, from Ilya, from Carlos over last years, and it was an incredible experience. I think exposure to different fields is very important. But there is some, I guess, balance. I don't know how to say it. Maybe my experience, because I started from medical field. I did my residency long time ago. Then I started lab. Then I did PhD. Then I did a couple postdocs in the US. Then I started another lab. Then I started clinical fellowship, and then started research again. So it was quite convoluted path, and I'm not sure I will recommend everyone to go this way, because it takes a lot of time, efforts, and also a lot of confusion what to do next. But definitely exposure to different fields is very important, because it helps you to see things in between and how different directions cross each other, and see clear questions what need to be done next, right? So again, talking to people from different fields also very helpful. It usually helps to find new solutions. So yeah, I guess this is important. And in terms of your question on how to submit and how to apply and what is success, I honestly don't know the answer. I just probably repeating everyone's saying, and what I feel personally is the only answer that exists. It's resilience and persistence. I hate to say this because it's a very common answer, but I want to emphasize that for many fields, especially when you have like your spouse who are doing something else, or your family members who, let's say, working in the field where you just master your skills, your knowledge, and you just use it for the rest of your life. In those cases, you probably don't need to take so many attempts. You master your skills, and then you're just quite efficient in those skills. It's even in medical field, but in science, the number of attempts, number of tries, it's incredibly high, and I will say in most of cases it's impossible to explain other people what it takes and even why you do this, why you're making those circles forever. And if there is any spiral of the circle, so it's just still the same circle you're going year by year by year. So again, resilience, persistence is probably the answer, but again, I have no idea how to explain this to other people who are not in science.
Yeah.
It's a hard one.
Yeah, thank you so much, Igor. And Mikhail, so what is that why behind the work you do that inspires you to do things over and over and still persevere and go into something that very often is absolutely unknown.
Well, we all study the brain, and the brain is very fascinating. And like if you compare this to some other problems that you could have been solving, at least to me, this looks more interesting. And the other part is, of course, that we do some practical work in the medical field, which potentially can improve lives of millions of people who suffer from neurological disorders. So this is also great. So with respect to our project specifically and why it was nominated for the award, this is very interesting because we do not offer any new technology like EEG, well-known, I don't know, responses to visual stimuli, well-known, virtual reality, not new, robotics, not new. But how we put it together, formulated this concept of how we do rehabilitation and how, for what purpose each component is there, this probably impressed the committee. And I think this is significant because I think for this same year, the project that won the award was on stent road. But stent road is just a technology, right? You can record when you place the electrode in a blood vessel. Also, in principle, this was known before. So, but it is a really nice technology. But it is different from our project because we introduced a concept. So, and we can use stent roads as well and some other ways. So, probably I think we should publish more, like to convince people that our way is the way to do rehabilitation, and hopefully we will advance in this even further. But also, of course, we have many more ideas what to do in neuroscience, what to do in neurorehabilitation. So we cannot cover this all in this podcast. But this is all very exciting. So hopefully we still have to do some exciting stuff in the years to come.
Yeah, thank you so much, Mikhail. If I'm correct, you also have been a committee chair on BCI Awards. Is that correct?
Yes, I was, but it was like 3 years before, something like this. Yeah. So I know how it works. Yeah, it works very democratic. There are like 10 committee members, and they all vote. And so the process is very fair, and at the end, like the best project wins.
Yes, and that's why I wanted to ask you, maybe you have some recommendations for people who are preparing their projects for BCI award submission, or what to look for, maybe, some tips that you can share with them.
First of all, be very clear, formulate your hypothesis well, do hypothesis-driven research, show the practical significance, and emphasize the novelty. Because what they use to show something that has been done before, just give us new ideas, and then they will win.
Okay, thank you so much, Mikhail. Very often, almost in all podcasts, I ask a question about doing the impossible. Because it's the main topic of our podcast, Neurocareers, doing the impossible. So, Carlos, I will start with you. Maybe you can recall something in your work, maybe in neuroscience, neurotechnologies, that seemed initially as impossible, but you made it possible. And how did you do it? So, what would be your main advice how to make the impossible possible?
Yeah, I think for me, it was very difficult actually to deal with patients because I was in the lab, so it's a very different facility. But I was afraid to deal with different personalities from the patients with this new approach and with all these different ideas from the patients and questions mainly. I could see the faces from different patients with all these expectation and so on. And for me, I think was the most difficult part. I would like to thank my advisor, especially Igor, because he's always supporting me. He's always collaborating with this project. And I think for me, it was a big step to jump from animal studies to human studies. So I think it was difficult, but at some point I knew that I had to try. And I'm very happy now with this path in, I will say, my career. So I would like to help other people with these new technologies, development of new approaches. And I'm learning a lot. And I think that's the main part here. So I'm really happy with this. So it wasn't impossible at all.
Thank you. So your advice would be, even in spite of not being comfortable with something, not sure how to do, try it. Yes?
Yes, excellent. I mean, if it's not maybe in your background and you have to do something different, just be brave, be confident, and try.
Thank you so much, Carlos. Ilya, as Igor mentioned, you and Mikhail were the two people who really advocated for project submission for BCI Award. Why do you think that was important? What advantages can this submission provide to those people who are submitting their projects?
First, if you are nominated, you are given some additional attention, and it improves your position in the neuroscience world, and specifically in BCI world, because the BCI award is no doubt the most prestigious BCI award worldwide, and it just helps you to persevere, because it encourages you. Besides, when you prepare your application, you might reconsider it to see your weak points, to see your strong points. If you receive feedback at any level from judges, from audience, definitely help you to improve your product, your technology, your ideas. So these are probably two main points to submit, and I encourage everyone. So we just spoke about this earlier with my colleagues. It's about 5 years ago, we already applied for BCI award. It went nowhere, but it was a great experience, and eventually it brought us to the list of nominees. So it definitely, if you like, if some group has something they would like to share, it definitely does make sense to try. Even though you won't be a winner, you won't be a nominee, it's a great experience nevertheless.
Yeah, I absolutely agree with you. Thank you, Ilya. Carlos just was talking about doing the impossible. That was my question. And I would like to ask you the same. Can you recall any experiences in your life, in your work, when you felt that some things are just impossible, they don't exist, and maybe, you don't see how they will exist, but nevertheless, you persevered and made that impossible possible? So maybe you can share that example and give an advice to our listeners of how to make the impossible possible.
So this project is definitely an impossible thing, and I still think this thing is impossible. But we made some part of it possible, so probably the other impossible parts will be possible as well. So when it started 7 years ago, I remember I was sitting in my office and convincing a person to join the project as a project manager, and he was totally from different field, absolutely knowing nothing about this, and he was asking me questions, hard questions, and I was answering. And at some point I caught myself on the thought, do I really believe in what I'm telling now? I'm not sure. Every day you have doubts. The thing is, you should know where to stop, but maybe it's more important to know where to not stop. Even though you don't believe, but you can believe in the future. Maybe today you will believe in this thing, try. It will cost you time. It will cost you money. It will cost you the neural cells. But you should believe in unbelievable. Then you must understand where to stop, but you still should believe in unbelievable.
Thank you. Thank you very much, Ilya. Igor, the same question for you.
I guess for my case, it's very important and something that I always trying to find is the reason to do things. Because, of course, we always see great stories of success and it's very inspiring. But I would say for me personally, it's very important to clearly understand and see in front of me people who really need this. And of course, it's patients, right? We definitely we're doing for patients, and having direct contact with those patients is very important. So you having this feedback. But it's also very important to see colleagues and students who need this to learn more and develop their own story. So I think this is another very important drive. So I will say those things probably the main reason for me to continue this work. And of course, it's very exciting when you see unexpected things happen. And in science, we see it time to time. And specifically for this project, it was pretty much unexpected. I would say the time when we saw patients being completely paralyzed, being able to move again, it was completely unexpected for everyone who was involved in the study. Even we already knew that we can facilitate some rhythmic activity in different models, even in human, and all the stuff that being developed by that time, it still was quite impressive. So I think this was definitely a very important part of drive. I guess those things probably the main points of trying to make impossible things. But again, I mean, if we in science, there is no question about possible and impossible. We just have to try new things, and new things they always new, and we don't know if they're possible or impossible. Actually, I remember the time when I was finishing my medical school and finished my residency, and first time I was moving from field that I was interested at that time. It was psychophysiology. I was moving to neurophysiology field, spinal cord, working with my PhD advisor, Dr. Gerasimenko, who's actually also on this award with other colleagues. And at that moment, I think I first time realized that what I was doing before that moment, it's not a new things. It's been already done by different groups, and I was just repeating several aspects, maybe trying to add some new parts, but overall it was old questions. And main excitement came when I realized I can read and experience some level of knowledge, and now I see a certain line, and behind this line there are new environment, new questions. And I think everyone who going through a PhD program can have this experience. Okay, now I can touch unexpected field, right? Something where no one really been able to touch anything yet. But then later you realize, okay, there are so many things you can touch. So I think this type of conceptual shift in the mind is important when you realize that, okay, now I can touch something that's never been touched before. And then you have understanding, okay, there are so many things you can touch. You have to really focus and be really focused on something that may work.
Yeah. Thank you so much, Igor. And Mikhail, the same question.
I actually had many experiences in my life when impossible became possible. So I will not tell you the most extreme stories, but I remember one of them. So we had some important demonstrations. Again, I will not go into very specifics. Like it involved the monkey and some intercontinental communication, and we had to be ready for some time. Yes, like everybody was ready, so the monkey was ready. And then some cleaning person came, started his machine, and all electricity went off. So I say, okay, we still have 5 minutes. So I turn on the electricity. The computer reboots, but the program doesn't work. So we say, interesting. It worked before. Why does it work? So we call the guy who wrote the software. He says, interesting. Probably the computer rebooted, but you need to use a different Linux kernel. So we rebooted the right Linux kernel. It's like 15 seconds, 10 seconds, 5 seconds, and then it starts, and then we connect. So, like, how are you doing, guys? Everything's fine. So this kind of stuff. But in reality, this is not how it works typically. Do not expect like miracles. Do not expect discoveries. Just do your work very carefully, involve all your friends, collaborators, and make sure you have the contributions from everybody. Every component works, and then it will be successful. So, and now I should probably say that you see just us here, but there are many more people who contributed to this work, and so this is only why we were able to get to the point where we are now.
Mhm. Thank you so much, Mikhail. And just to sum up, we had an advice of try it, even you are not comfortable with that, you are not sure about it. Believe in the impossible. That was from Ilia. And see the reason behind. Yes, the real people, the real patients behind the work. And I really like that concept that do not make an assumption whether the things are possible or impossible. Yes, just do it and see for yourself. Be a real scientist. Yes, so we should not have an a priori notion already, possible or impossible it is. And of course, many shifts in your understanding of how the things work will happen. And then, Mikhail, ensure all the components work. Yes, and everything is in place and it will eventually work out. So thank you so much for all this wonderful advice. And as we are nearing the end of our podcast, I would like to ask each of you to provide information to our listeners of where to find information about the work you are doing, how to contact you, and maybe just the last piece of advice, or any suggestions, anything you want to tell our listeners. And Igor, maybe we'll start with you.
Well, I guess the best way to contact any of us by email. I guess also if something is important, and especially if someone wants to collaborate or wants to join the team. I mean, we have a few teams right in the loop. I guess advice if some of us is not replying, please hit another one or just repeat email, because sometimes there are so many deadlines we just overwhelm with ongoing things. Overall, I think the idea of what we are doing is definitely coming from excitement, and I hope we had a chance to share this excitement to some extent with everyone. And I really appreciate what you're doing to provide more excitement from other teams and can help people to learn this. I mean, there is no doubt that BCI and neuroscience will change a lot. And like in ultimate world, ultimate case, we can see that it will change our communication, it will replace our phones, it will help to gather information in a totally new way, it will help us to learn, augment our mental capacities, probably, right? It may help us, it likely will change in entertainment at all. You may see new forms of movies, art, new forms of art and theaters, right? It's be probably more interactive. And definitely all those points will come just by itself with a lot of efforts that we will not see personally, but it will provide a lot of excitement. And I think staying on that level will really be important to kind of always think about science, about questions we still can target. And I think within those questions, we definitely need technology that will be likely more invasive, like multi-channel DBS and multi-channel systems for integrating with brain. I think there's definitely going to be a one direction. Another direction will go in entirely opposite way, with being less invasive, but targeting more specific function. I think will be developing in parallel, and we need to think about this different modalities, of course, because so far we've been talking today, I guess, about electrical modality, right? About electrical field, how we record and how we stimulate. It's kind of the same way, but there are so many other options with magnetic field, with ultrasound. I think we definitely will see more improvement on that level. And also interfacing the brain, it's what we're talking always, but it's very exciting to think about interfacing brainstem, interfacing spinal cord, and interfacing all level of central nervous system to provide optimal impact. And again, bidirectional interfacing, right? Like even on spinal cord, we already have enough data saying that we can use electrical modality to stimulate and to record. We record so-called ECAP to optimize stimulation, provide closed loop. We have excellent data with ultrasound where we can record changes in the blood flow very locally when we stimulate. There are ways to stimulate with also ultrasound as well. So again, it will be more and more interfacing on multiple levels. And then again, we will come to the question about the system level, how we will put those pieces together and what we need to learn about function, about organization. So we may go these loops many times, and we likely will go soon back to basic questions, how we exist and how we are organized on that level. So again, I think all those questions will be important. And again, I appreciate your work that you've been doing to facilitate this excitement and getting people to share it. Thank you.
Thank you very much, Igor. Thank you. Mikhail.
So contacting me or any of us is very easy. Email or Facebook, Instagram, Twitter, Telegram. So all these ways, they all work. We can Zoom. Actually, this Zoom was absolutely the best in, I don't know, last 3 years. Because normally when I'm at Zoom, I start to get sleepy on minute 5, then I go with all phases of sleep. So I hated Zoom, but this time it's great. So great conversation. But hopefully we will meet at some point in normal way, reunite, and so because the best way for primates to communicate is real communication. So. Let's shoot for this.
Let's do it. Thank you so much, Mikhail. Carlos, what is the best way to learn about what you do? Contact you, and maybe you can share some advice or some, words as we're nearing our podcast thing.
Yeah, first of all, I would like to thank you for this amazing opportunity for sharing our thoughts or ideas, future directions. So yes, for your listeners, feel free to contact me, contact all the team. I will be really happy to hear back from you. You can provide also some feedback from your thoughts about this project. I will be really happy to hear back from you. And so thank you for this conversation. Also, Igor, Ilia, I can pronounce your name correctly now, Ilia, and Mikhail, thank you. This was a very great opportunity. So final advice, I will say, maybe for scientists, impossible is forbidden word.
Yeah, thank you very much, Carlos. And Ilia, your concluding statement for this podcast.
Yeah, thank you. Thank you for inviting all of us. And it was my first time participation in podcast recording. And I hope it was not that terrible. And it was a very interesting experience. And I 100% agree with Michael. I wasn't sleepy for any not a second. It was a very interesting conversation. And it can be so interesting to talk with people who you know for years, but we were able to find something new in each other, probably. Thanks very much for this, Milena, because you were asking very right questions. And how do we share what happens in VIBRAINT? As we have a website, which is quite static and ugly, but we also have social media. And VIBRAINT.ai is our website address, VIBRAINT, YABRAINT.ai. look for VIBRAINT AI in LinkedIn, Twitter, Facebook, and we try to share any news we have, and I hope we will publish the link to the podcast there as well. Welcome.
Yes, absolutely. Thank you so much, Ilia. Yes, all the information will be published in our podcast notes, and our listeners will have opportunity to connect with you and learn about what you are doing, also provide feedback. So thank you very much for all this information. I want to thank all of you for this exciting conversation. I think very inspiring conversation, and I'm sure our listeners will enjoy listening to it. I wish you all possible success in your amazing endeavors and look forward to the follow-ups on your new results, on your progress. Maybe in a couple of years, we can have another podcast and see where you are next and learn from you. Thank you so much. Are you a fearless pioneer in the world of brain-computer interfaces? Do you have an amazing project that's pushing the boundaries of what's possible? Then we want to hear from you. The International BCI Award is one of the biggest and most prestigious awards in the BCI world, and the deadline for submission is September 1st. But don't worry, you don't need a top-notch budget or equipment to be a nominee or a winner. All it takes is a great idea and the determination to make the impossible possible. So, submit your project now at bci-award.com or find the link in our podcast notes and join us on this incredible journey to explore the world of BCIs. And make sure to listen to our upcoming BCI Award Neurocareers podcast series for tips and tricks on creating a successful submission. Who knows? You might be the next nominee or winner of the International BCI Award and proudly showcase your nomination on your resume to impress potential employers and establish a successful career in neurotechnologies. But don't stop there. If you're looking for more guidance on succeeding in neurocareers, book a free consultation with me, your podcast host, Dr. K, at the Institute of Neuro Approaches. So, what are you waiting for? Let's make the impossible possible together.